So let's solve this particular differential equation. We begin by rewriting this differential equation. So we have dy over dx. So that will be given by y times x multiplied to cosine of y over x plus y multiplied to sine of y over x. Whole thing divided by x multiplied to y times sine y of x minus x times cosine of y over x. So this is a homogeneous differential equation. The reason being, if we consider the expression in the numerator, so let's say it's represented by the function f of x comma y. So we have, so if we substitute x with lambda x and y with lambda times y, then we get lambda square times f of x comma y. So this is the criterion for a homogeneous function. So we have f of x comma y, which is a homogeneous function with degree 2. Similarly, if we consider the function in the denominator, so that will also be a homogeneous function of degree 2. So since both the numerator and the denominator are homogeneous function, so we have a homogeneous differential equation. Now in order to solve such type of differential equation, all we have to do is consider y equals to v times x and then differentiate both sides, and this will give us dy over dx equals to v plus x times dv over dx. So what we'll do, in place of dy over dx, we will have v plus x times dv over dx, and here accordingly y will be substituted with vx. So let's do that. So we have v plus x times dv over dx equals to, so in place of y we have v times x multiplied to x times cosine of, so y over x will become v plus y, so that's v times x multiplied to sine v. Whole thing divided by x times, so we have y, so y will be v times x times sine v minus x times cosine of v. Right. So we can factor out the x. So that will give us v plus x times dv over dx. This will be equals to vx squared times cosine of v plus v sine v, whole divided by x squared times v sine v minus cosine of v. So the x squared terms gets cancelled out, and that leaves us with, next we will subtract v from both sides and we'll combine the two terms on the right hand side to get, so we have x times dv over dx. So this will be equals to, so we have v sine v minus cosine of v in the denominator, and in the numerator we have v times cosine of v plus v squared times sine v minus v times the denominator, so that will be v squared sine v plus v times cosine v. So v squared sine v goes away, and this leaves us with 2v cosine v divided by v sine v minus cosine v. Now what we can do, we can separate the differentials to get v sine v minus cosine v all divided by v cosine v times dv. So this will be equals to 2 times dx over x. So this is in the separable form. So what we can do, we can integrate both sides. Now, to perform the integration on the left hand side, all we have to do is make a substitution. V times cosine of v equals to a variable t. Then this will give us negative v sine v plus cosine v dv equals to dt. So that means our integral on the left hand side becomes negative dt over t, which will be equals to 2 times dx over x. So this is a fairly simple integral. So this will be negative log t equals to 2 log x. Since everything is in terms of logarithm, so our constant of integration, let's take it in terms of log. So let's take log of I. So we'll use some property of logarithm. So we have negative log of t. So that's simply 1 over t. This will be equals to log of x squared times I. Now we can get rid of the logarithm from both sides. So we have 1 over t equals to x squared times a. So let's substitute the value of t. So we assume that t is equals to 1 over v times cosine of v. So this is x squared times a. Also we have to take the absolute value. And v is y over x. So we have x over y times cosine of y over x. So this is equals to absolute value of x squared times a. Or simply, we can rewrite everything to get x, y, cosine of y over x. So this will be equals to the constant of integration. So this is the final and required solution to our given homogeneous differential equation.